So I'm Leonie, and you've already met me a few times, probably, these past few days. I've been working on helping solve exactly what people have been presenting today as issues in the publishing industry. I won't go very deep into this because Frederica, Philip, and Boris have already done so today. So I'm very thankful for their introductions. What I'm talking about today is actually our product, and I'm going to present a little bit of that, a little bit more in depth than Philip has done. And I'm talking about, so it's fair enabling research objects on persistent IDs, which is a very core sentence from this, but there's a lot more that goes on this. If you know what fair is, how many of you know what fair is? Okay, so FAIR is basically ensuring that both data, but in this case also research, is findable, accessible, interoperable, and reusable. So basically you share it for it to be continued sharing. Now I'm going to do another quick poll. How many of you have been in research? Okay, can you please keep your hands up? Next question, if this applies to you, please take your hand down. And that is, how many of you have published most or everything of your research? Okay, so that doesn't leave many. How many of those people have had their work cited? So please keep your hands up. All of your work? Okay. And how many of you have had all of your data reused? No, there's not that much left. We have one person left in the room today. So actually, this goes across a lot of research. Basically, from being registered, this is in the case for the medical industry, from being registered, we get that medical trials actually lead to only about 50% of publications. And from those publications, only about 50%, so another half, gets cited. There has been another study that says about 85% of research is wasted and doesn't even make it to publication. And that is interesting. And all of this doesn't even talk about data because generally data isn't even shared, let alone reused, because even when it is shared, it's very often in a form that is either difficult to access or difficult to understand, so not reusable. So from that, on top of that, you basically have all the other issues that we've talked about, but also things like aging publishing infrastructure. What we currently have is actually an infrastructure that has been built a long time ago, and we're still publishing on it, but it isn't ready for AI. There is things like poor UX and fragmentation happening. There's a lot of content drift, which I'm going to go into, and there's bad incentives. There's not a lot, for example, connection between funders and scientists. And when there is, these are often famous scientists who actually get prioritized in funding, and so you actually have less distribution happening in funding as well. And then, of course, we've also spoken about the limited metrics. Now, one example of the aging infrastructure is actually URIs, where URIs actually point where content is stored. It doesn't actually point to the content itself. And this means that over time, the content kind of disappears because you no longer have a proper link to it, either because files get deleted or other things happen to it. And so they've looked actually at what happens with link rot over here. Let's see. Over here, you can see that even from 1997, a large part of it is actually no longer accessible or even useful. So this is a bit of a shame. There is no persistence here. On top of that, we have the DOI system, which is an excessively respected system and very often indicates for researchers that their paper has been, in a way, officially or unofficially recognized as something that is an object of academic interest in some sort of way. The thing is, though, that DOIs are also actually, as they were a fantastic solution at the time, but they've aged a little bit, partially because there is a lot of struggle in both making DOIs resolve to just one target. There's a lot of target overlap. Also, so they're not unique And on top of that, the DOI is actually also not entirely persistent to just the object. So objects can disappear as well. So you've got link rot going on. And then match to URLs. The matching used to happen by hand. I think there might be a little bit of automation going on there, but it kind of means that there is a lot of work involved in assigning DOIs. So it's not an automated system. This kind of means that DOIs are also, in a way, an aging persistent object where there is room for optimization. So this is all sort of the infrastructure that then things like the UX, the user experience, are built on top of. This is the flow of UX. There's a few different panels here that people have to go through to, in this case, actually add a link to their data that is put on another platform. So this isn't even adding your data to the manuscript that you're submitting here, but it is adding a link to the data that is present on another platform. And this is what people have to go through to do that, which is extremely time-consuming for people who don't have that much time. So, here we go. So you see that there is an excessive amount of fragmentation going on in almost every single layer related to online publishing. And on top of that, you've got this other set of fragmentation where, yes, we have all these different solutions for what we want to do and what we want to cater to. There's GitHub, which is fantastic, but does it work with Dropbox? No, it's not interoperable. You cannot interoperate between all of these different platforms. And it's not like you actually have a data hub available on most of the data repositories that have the code in it. So you're basically publishing not just a manuscript, you're publishing your data, you're publishing your code and everything in a different place. And so what we're trying to solve is to ensure that we can publish everything in one place. You have it all linked together, and these links, as well as the objects themselves, don't rot away over time. They don't disappear. You actually have a stable link to them. And that is what we're doing with DeSci Nodes, where we also actually hope to make the system really easy to actually make data more representable. Though at the moment, it is much a system where you can just publish everything in one place. What are we trying to do with this? We're trying to enhance the trust in science, basically making things reproducible and reusable, but also in a way, reproducible so you can actually see what other people have been doing all the way from whenever they start publishing to when they actually decide to share it officially. When they start their work and put it online to when they decide to share it officially. Increase the research ROI, the reproducibility, meta-science proving grounds, basically adding the different metrics to, you don't just add your data, you also give metadata on your data. So you can explain different things about your data when you have it on here. So it's not just standalone data, you can explain what it is and how it works and how you worked with it. Future-proof, we're trying to ensure that AI will be able to recognize which parts are what and what applies to what as well, so that it can be easily read and reproduced by it if you want to. I'm not sure how we will silo it, but I'm pretty sure that we have enough people who would want to have AI applicable and enough people who would not want AI to be able to read everything at the same time. Equip scientists with modern publication flow. So basically, make it really easy for people to publish, or at least in this case, pre-publish. Compute-enabled publications, verifiable attestations, which is stuff that Philip talked about earlier, and translate the AI for AI readiness. Basically, this system, if you think about it, it's a little bit like creating a Google Suite for academics that also has a preprint section, publication section, and a little bit of a Wikipedia edge. Now, I think that kind of gets to what Federico was saying this morning. That seems like a hell of a lot of confusion on one blockchain product. I will try and show to you that you can actually do this in a way that is relatively easy and straightforward to do. But yes, as this is a blockchain place, sorry for using the word blockchain to Boris, but there we go. It's still blockchain. I wanted to explain to you how this actually works for the blockchain part. So how do we make this persistent? What we do is we actually create the object itself is just a number 1 over here, is the node, and we attach everything associated with it. So basically your manuscript, your code, and your data, we connect it in hashes to the base root node, so the root hash. And we connect that to the node ID over here. And then when you change something, what happens? For example, you add a video over here. What changes is the hash, but the research object stays the same. So you actually, it is kind of like creating a bucket over here that contains all these different objects in it. And the hash sits on a ledger and actually gets published on the blockchain and has a gets published on the blockchain over here. So that stays stable through the blockchain. What you can then do, and this is basically another part of what we have been developing, and that might be interesting to you because of the blockchain element, but we're also creating a special DPID registry. So we've been creating a separate way of registering on the blockchain, so a different persistent identifier. And with that persistent identifier, we actually hope that people can just work quite easily with that within different applications. So for example, when you're working with just this one object instead of the entire sort of set over here, it might be easier to import and work with data across different applications. But yeah, that is something that we'll hopefully launch very soon, which is another product coming out of DeSci Labs. Yeah, what you see over here is basically that also when you change a document, it actually gets a new hash. So over here, the manuscript has been updated, and over here, the hash has changed compared to earlier. Now, what you can do as well is add all these different attestations or other sort of characters of your node to it as well. So you can attach that to what is happening over here separately. And yeah, this is a little bit of a demo of how this works. There will be a larger one after this. Thank you. So that was an overview of the different publications. This is one of the publications that has now been selected. You can select the data and look at it. These are all the different sort of hashes on there. This is the manuscript, so you can simply browse through it. This is the selection menu. So you've got all your data over here, and you can download the data right away, just from inside the app. Similarly, there are different other information files, like the license. It's just a manuscript anyway, so you can upload it. So it's just a data file. And here you can see that we don't just stay in the platform, but you can even link out to other platforms if necessary, if that is where data or code sits. So in that case, it was the code that was sitting elsewhere, and you can easily link out to it. Now that is nodes. What we've also found is that we're actually having trouble finding the right connection with people and scientists. And that it also feeds a little bit into what Boris was saying, that for research, what academics really want is fast publication in a good journal with minimal effort. And so what we have seen happen, actually, and this is just an NS1 user case, but we want to test this out and see if this actually helps others as well, is that having these nodes available to editors and actually adding them into when you hand in your manuscript with a link to your node which has all the data and code in it, has, for one of our people, in this case Philip, facilitated a 2-week turnaround with Nature and an acceptance with them. Now, generally, 2 weeks is not going to happen for a publication like that. So we think that the fact that he made all of his data available online, also very quickly viewable to the editors, as well as the code and all other materials, in a way that is actually pretty easy for the editors to navigate and access, might have facilitated in this turnaround being so fast and them being quite interested in publishing it, or at least heightening the interest in publishing it. We want to test this out, so we would love it if researchers tested this out as well. But what we've done is actually to try facilitate this even more in a way that is intuitive, so actually guiding people through to submit it, to uploading their manuscript, making the submission package by adding their data and other materials, and then having like both a node but also like a research, a manuscript, where we add in this part, this information page that kind of gives the links to the data and code and the node itself embedded in the top. It also gives information of the license that applies to it, that you can add information on the node too. And you can apply for the badges that I think Philip mentioned earlier as well. So you can add claims to your paper and say, okay, I've created open code, I've created open data, and I've made it reproducible. And what they can see as well, what they will be able to see in nodes is whether people have actually verified this. So people can verify this on the platform, and editors can very quickly see whether other people agree that there is open code and open data. So there's a very small part of the review process already happening for them. And this is what that part looks like. So here, the manuscript is uploaded. Here we add data and code. So basically, we can just drag and drop it in, which is excessively easy. I love this myself. And literally, you're just uploading 308 files. You could see there was a folder I dropped in there, and it actually extracted the files from it straight away. So you don't even have to go and select every file separately. You can just drop a folder in. In this case, we have connected it directly to OrcID. So you can actually, when you add the contributors, you can type the name and it will search for them on OrcID, and you can add in their OrcID profile straight away from there if you want to. And the previous step, you can add the badges. Now it's creating the package, and it creates a node straight away at the same time. So you have both a package that you can submit, basically being your manuscript, with the extra title page, and you have the node created for you on the platform straight away as well. And here you can see that you can actually share this node through a link with your collaborators and fellow authors, so they can quickly look at what changes might have occurred in the meantime. And yeah, that is kind of it for now. We're about to launch a new version that we feel is a little bit more approachable for academics. We've gone away from black, so enjoy the black whilst you can. We're going white. There you go. Thank you.
Thank you. We won't. Yeah, see.
Do be aware, I've given the extra information of where to go for this, but it's not compatible with your mobile phone, so it will look much better on your computer.